Hey students, this is lesson 6.5. In this lesson, we're going to learn how to determine whether a parallelogram is a rhombus or a rectangle. Go ahead and do the review, and I'll check back with you. All right, here's the theorems we're going to use. In general, let's just try and say what the theorem is as opposed to using these numbers, but if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So go ahead and use those two to do 7, 8, 9, and theorem 618 to do 10 through 12. All right, let's do problem 1 here. It says, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Explain. And the first one, this piece here is congruent to this piece, and that's congruent to that piece. So we know that 7 plus 7 is 14, and 14 is equal to 14 by the reflexive property. And so we can say that this is a rectangle. And the reason we're going to say that is because rectangles have congruent diagonals. And the second figure here, it looks like a rhombus. And the way we can tell that it actually is a rhombus is because if a parallelogram has perpendicular diagonals, then the figure is a rhombus. That's theorem 616. So we know that this is perpendicular because of the 90-degree angle shown there. So we'll say this is a rhombus. And our reason is because parallelograms with perpendicular diagonals are a rhombus. All right, you try it here. Read the words and try and figure out what figure they're talking about. All right, we'll use these properties here to solve the problem. For what value of x is the parallelogram ABCD a square? So since we know this is a parallelogram, we know that opposite sides are the same. And we also know that the diagonals are perpendicular. If the sides are all the same and it's a rhombus, then the diagonals are perpendicular. So we could say that 6x plus 6 is equal to 90. And that's because rhombuses and squares have perpendicular diagonals. And then we'll just use the subtraction property of equality, and we get 6x equals 84. Using the division property of equality, we get x equals 14. All right, go ahead and try problem 2. All right, using properties of parallelograms in real life, describe how you could use two strings to mark the four corners of a rectangle. So, in order to have a rectangle, we would have to have congruent diagonals that bisect each other. And the reason they have congruent diagonals, that's a theorem we just learned, but they bisect each other. We know that because all parallelograms have diagonals that bisect each other. So what we could do with the strings is cut the two strings to equal length. And we would use those for the diagonals. Then we would fold each string in half to find the midpoint and just mark those midpoints. Then we would just stretch the strings diagonally and match up the midpoints. Then we are guaranteed to have a rectangle if we use the endpoints of the two strings as the vertices. And the reason we would know that this is a rectangle is because the strings are the same length, so we have congruent diagonals, and we are bisecting the diagonals, so we know it's a parallelogram also. All right, you try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll discuss your answers next time we meet in class.